Welcome to Algebra 1. The learning goal for this episode is to learn how to solve equations involving proportions and percents. First, some necessary vocabulary. A ratio is a comparison of two numbers by division. So, for example, the ratio of 1 to 4 can be written as 1 to 4, as 1:4, or as a fraction 1/4. Recall that a fraction bar means division. A percent is a special kind of ratio that has 100 in the denominator. It might help to remember that percent means per hundred. A proportion is an equation that states that two ratios are equivalent. For example, 2/5 equals 4/10. Let's look at some examples. Sometimes you can guess the answer to these problems, but we want to learn a procedure that works even if we can't guess the solution. In this example, we are trying to figure out what number x, that when we divide it by 12, is equivalent to 65 divided by 156. Since we know that our unknown number x, our variable, equals 65 divided by 156 after we divide it by 12, we can work backwards to figure out what x is. So, working backwards, if we want to undo dividing by 12, the opposite of dividing by 12 would be multiplying by 12. In mathematics, the opposite operation is called the inverse operation. It's very important when solving equations to always do the same thing to both sides of the equation. That's the only way to make sure both sides of the equal sign stay equal. So, we multiply both sides of the equation by 12. On the left side of our equation, we simply get x, since the 12's divide out. On the right side, we can use our calculator to simplify. The easiest way to do this on your calculator would be to multiply 65 times 12, then divide by 156. This gives us a solution to the equation with x being equal to 5. It's always a good idea to check to see if our answer is reasonable. If I look back at the original proportion and fill in 5 for x, I get 5/12 equal to 65 156. Does that seem reasonable? Well, 5 is a little less than half of 12, and 65 is a little less than half of 156, so it does seem reasonable. If I want, I can actually use my calculator and divide out both sides to check my solution. So if I divide 5 by 12, and then do 65 divided by 156, they are indeed equal, so my solution checks. Let's try another example. This one involves percent. What percent of 80 is 48? Recall that percents are a special kind of ratio with 100 in the denominator. We can set up a proportion for this type of problem by equating the ratios part over whole equals percent over 100. For this problem, 48 is the part and 80 is the whole. We don't know the percent, so we put our variable over the 100. You can use any letter you want. I used p. We're trying to figure out what number p that when divided by 100 is equal to 48 divided by 80. So we want to do the opposite or the inverse of dividing by 100, so we multiply both sides by 100. Then we simplify. 100 times 48 divided by 80 gives us 60 for p. That means our solution is 60%. 48 is 60% of 80. Again, we want to make sure our answer is reasonable. 60% is a little more than half. Is 48 a little more than half of 80? It is, so our answer seems reasonable. If we want to check it exactly, we can use our calculator to divide out both sides of the equation. 48 divided by 80 and 60 divided by 100 both work out to be 0.6, so our solution checks. Let's do one more example. 660 is 22% of what number? We should now be able to set this up pretty quickly, thinking about part over whole equals percent over 100. In this case, we know the part and the percent, but not the whole. We can use any variable for our unknown. I chose to use w. But now we have a problem. We can't solve this like the previous proportion problem because our variable is in the denominator. So we can take what we already know about fractions to write an equivalent proportion. We know that if any two fractions are equal, then their reciprocals are also equal. So we take the reciprocal of both sides, flip them, and write an equivalent proportion. W over 660 equals 100 over 22. Now, we know how to solve this proportion. Since w is divided by 660, we do the inverse or opposite and multiply by 660. That gives us an answer of 3,000. Does that seem reasonable? Yes, it does. 10% of 3,000 would be 300, so 20% would be 600. Since 660 is a little more than 600, and 22% is a little more than 20%, our answer seems reasonable. Just a quick note about something called cross products. You may have previously learned that you can solve proportions by taking the cross product. In this case, that's multiplying w times 22 and getting 22w on the left side, then taking 660 times 100 and getting 66,000 on the right side, which gives you 22w equal to 66,000. You would then solve this equation by dividing both sides by 22. Cross products work fine, and there's nothing wrong with using them. I prefer not to use them because they obscure the meaning of what we are doing. You may know that you can use cross products to solve proportions, but you may not be able to explain why it works. By solving it the way we've been solving it, thinking about inverse operations, then you're sure to know why you're solving the proportion the way you are. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step I'm going to prompt you with the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? What we're trying to do is figure out what percent of 120 14.4 is. Your next question is, what do we do first? We think about how we set up percent problems as part over whole equals percent over 100. Now what? Now we substitute in 14.4 for our part and 120 for our whole and set that equal to some variable, I chose p, over 100. What's next? Since we want to figure out what p is, we need to undo the dividing by 100. We do that by multiplying both sides of the equation by 100. Now what? Now we simplify. 100 times 14.4 divided by 120 gives us 12 for p. 14.4 is 12% of 120. Are we finished? Yes, we are, but it's always good to check the reasonableness of our answer. Is our answer reasonable? Yes, it is. 10% of 120 would be 12, so it's reasonable that 14.4 could be 12% of 120. Let's go through that process again. What are we trying to do? We're trying to figure out what number, that when we take 56% of it, gives us 448. What's our first step? Our first step is to set up part over whole equals p over 100. Now what? Now we substitute in 448 for our part and 56 for our percent. Since we don't know our whole, we put a variable there. I chose to use w. What's next? Since our variable is in the denominator, we write an equivalent proportion by writing the reciprocals of both sides of our equation. Now what do we do? Since w is divided by 448, we want to do the opposite, so we multiply by 448. What's our next step? We simplify. 100 times 448, then divide by 56, gives us an answer of 800 for our whole. Is that reasonable? Yes, it is. 56% is a little more than half of something. 448 is a little more than half of 800, so our answer is reasonable. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here's the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve equations involving proportions and percents. We did that by multiplying both sides of our equation by whatever number our variable is divided by. If our proportion had a variable on the bottom, we learned we could write the reciprocal of both sides of the equation and they would still be equal. We also learned that percents were a special kind of proportion that we could set up as part over whole equals percent over 100. Remember, you can always go back and replay portions of this video if you need to see it again.